The binomial distribution. When we talk about the binomial distribution, it's again for a purpose. The word binomial means bi means two. So the word binomial means two, something to do with two. So bi means two, nomial means terms. So binomial distribution deals with two terms. Now it's a distribution where we have something where any one of the two can happen. It has to happen. In Poisson distribution, something that might never happen, but here one of the two has to happen. If you toss a coin, either it's going to be a head or a tail. One of the thing is called a success and the other thing is called a failure, not necessarily in a good way or a bad way. Success does not mean a good thing, but it has to be said. Something has to be called a success or a failure. So situations where there is either something happening or something else happening, meaning something happening or not happening, the probability of something happening, if we consider it to be P, let me call it the probability of success, then by definition the probability of something not happening, let me use the letter Q, is going to be 1 minus probability of success. The other thing is, it is like if something happening is 70% chance, something not happening is going to be 30% chance. So this concept of one of the two, binomial, that is very important. One of the more important thing about binomial distribution is to remember there is actually a concept of binomial series where two terms are expanded. That concept is also very important here. So for example, in high school math there is a basic concept of the binomial series. The binomial series looks like that. A little review is needed here. So binomial series is something like two terms expanded. It can be a plus b whole squared. So it is a squared plus 2ab plus b squared, and there it can be a plus b whole cubed. It is a cubed plus 3a square b plus 3ab squared plus b cubed. So similarly, if we consider it to be a plus b to the power n, a general term, then the rule for binomial series to expand it is the first one to the power n and also the last one to the power n, and between it is going to be a rule called combination, nc1, the first one to the power n minus 1, the second one to the power 1, plus nc2, the first one to the power n minus 2, the second one to the power 2, plus nc3, the first one to the power n minus 3 and the second one to the power 3. So that's how it works. So this is the idea behind binomial series that's in high school. Another generic term can be a plus b to the power n, can be written as the rule is some sort of a summation of nc x, a to the power n minus x, b to the power x. We can use x or r, both of it. So this is the idea, the background for binomial series. Now while talking about the binomial distribution, we have to use this because it is important to remember that every distribution is made up of random variable. So in case of binomial, it is a discrete, again discrete random variable here. So the random variable, so the definition of the random variable here is going to be number of successes. Here is no other information required. Number of success, again success does not mean a good thing or a bad thing. It's just how you say the information that is given, that is the success. Now what information will be given? A binomial distribution requires two information. Before mentioning that, let me talk about why do we use the binomial distribution. What is the reason why or when to use this distribution? The first thing that we have to understand about using the binomial distribution, that in every case there has to be two outcomes. So there are two outcomes. we call them a success, denoted by P, the probability of success, and failure, denoted by Q. Now that's one of the reasons. So one reason is there should be two outcomes. So if you're tossing a coin, it can be head or a tail, so we can consider it to be a binomial distribution. Another thing is the number of trials must be fixed. Number of trials must be fixed. That means you have to repeat that thing. If you are tossing a coin, you have to repeat it, but you have to fix it. If you want to repeat it 10 times, 20 times, 30 times, fix it so that you can repeat it as much as you can. So you cannot just say, oh no, not 10, 15 or something else. It has to be fixed. So the number of trials has to be fixed. What is the number of trials? What is trial? Trial is something, some sort of an experiment that can be repeated. Now if you have something that you blow up, you cannot repeat it, so it has to be something that can be repeated, and you can perform the probability, you can check the probability from it. Now one more thing is that the trials must be independent. The trials must be independent. Independent means one trial should not be dependent on another trial. If someone is picking colored items from a bag, if you keep removing the item, they are not independent, because pretty soon one of the color would run out. So the next one is definitely not going to be that color because someone has already taken them. So trials has to be independent. And the final thing is that the probability of the success must be constant, meaning also the failure must be constant. You cannot just keep changing the probability. So probability of success must be constant. So that is very important, that the probability of success must be constant. So when we have these four things happening, either a success or a failure, number of trials fixed, trials are independent of each other, and the probability of success is constant, it's not changing, then we can say we can use the binomial distribution. So for defining the binomial distribution, the random variable x is distributed by the binomial distribution denoted by the symbol b. Is the parameters needed is n, number of trials, and p, probability of success. So the symbol for trials is n that we use. So this is what we need to know in order to do the binomial distribution. Now the question is, what is the formula for finding the probability? So we always have a table where the random variable is given and the probability is given. Since the binomial distribution is going to be very big, we usually don't have a table. It is given to us, it's provided to us in the exam. So the binomial distribution PDF, the formula is similar to this, similar to what has been done in basic pure math series. So that's what is done, but the difference is that here, instead of this, we consider the failure first and success later on. So it is rather q plus p to the power n. So here it is going to be, using this formula, it is going to be ncx q to the power n minus x p to the power x. So the formula for the probability, if someone wants to find the probability of a random variable, suppose it's the value x, small letter x is the value, so it is going to be ncx q to the power n minus x p to the power x. Now what is this thing called c? All I'm going to say about that is it is called combination. This c symbol means combination. It falls under the topic of combinatorics, something called combinatorics, and it can be found from the calculator. There is a button usually above the multiplication button in orange color, or the division button in orange color. Orange color means you have to press another button in the calculator to access that. So in that button, if you access that, you can find that value, so from the calculator. So in binomial distribution, the most important thing to remember is the random variable is discrete. Defining the random variable is number of successes. So if in a sum they say the probability of something is this, well, the number of successes is going to be the random variable, and the parameters needed for this is number of trials and the probability of success. One thing that must be mentioned about the binomial distribution as well, just as an additional information, is in binomial distribution the expected value or the mean. In Poisson distribution, the expected value is the mean, the mu is given, and also the variance is also the same as the expected value. So in binomial distribution, the mean, which is the expected value, is given by n multiplied by p, the number of trials multiplied by the probability of success, meaning out of this many times what is the percentage of being successful, so that percentage is the expected value. And the variance, which is standard deviation whole squared, variance is n p q. Of course, q means 1 minus p. So npq, that is the variance. So the expectation or the mean can be found out like that, and the variance can be found this way. So this is very, very important. In Poisson distribution, both the mean and the variance are equal. So mu equals to expected value equals to variance, they are all equal. So that's the situation in Poisson.